Image captioning using neural networks. Hi, my name is Linda, and I'm a data scientist on a quest to automate the picture captioning struggles in my life. On the professional side, storyboards would have been much easier if I could automate the captions. In my personal life, I keep procrastinating on my son's photo books because I really don't want to write the captions. Joking aside, my real motivation here is to learn how new technologies are combining computer vision and natural language processing to accomplish amazing things. For example, a visually impaired person can point their camera at the scene in front of them and hear a spoken description. I think that's awesome and very empowering for the blind. The goal of this project was to use neural networks to generate image captions. I used the Microsoft COCO dataset, and the main tools I used in this project were Python, Tensorflow, and Google Colab. I combined a couple different models to translate these images into words, which I'll go into further. Before going into the modeling though, I had to pre-process the images and the captions. I extracted features from the images using Inception v3, and the image representation at that last convolutional layer of the neural network becomes the input for my encoder. To prepare the captions, I had to first tokenize the words to make a token sequence. Then the vocabulary is just a dictionary with each word assigned to a number. Because computers prefer numbers, each token sequence is then transformed into a number sequence. And finally, the decoder requires all captions to be the same length, so I added pad tokens as necessary. So once the image passes through the encoder, the RNN decoder processes the features to make sequential word predictions using visual attention. The output is a caption prediction. So in my model, I ran 20 epochs with an Atom optimizer, and my loss was a little over 30%, so I knew my captions wouldn't be perfect. Let's take a look at a few. Here are 3 examples of good predictions my model made. They're not as specific as the actual captions, but I think they're still pretty good. Earlier, I mentioned visual attention in the decoder. While the predicted caption of a farm neon sign on a wooden pole is not great, take a look at the word neon on the attention plot. You can see the visual attention lights just light up around the yellow portion of the sign. So when you look at the attention plot, it helps you visualize why the model might have predicted certain words, even if you or I can tell that it's not a neon sign. One issue I noticed as I ran through validation images was repeated words. Ball on ball, giraffe being repeated in the picture on the right. And on top of that, I also noticed that my model seemed a little biased towards baseballs and giraffes. So I did what any curious data scientist would do. And I looked for a giraffe baseball picture just to see how my model would do. Not great with image of a ball in a ball in a ball. With the other random images, the captions were also pretty bad. I'm guessing video chat room images weren't a common training image in 2014 when this dataset was created. And the picture of Donald Trump only confirms my model's bias for giraffes. Finally, the last set of images I ran through my model were a few of my personal photos. You know, for that photo book that I'll definitely really get to soon after this project. I'm seeing that same repetition and incorrect captions, but on the bright side, it didn't predict giraffes for my photo. In conclusion, my model is not quite ready for deployment, but there's still hope for my automated photo book. Improvements I can make to my model include different tokenizers, utilizing transformers, and of course, run a few more epochs. I'm really excited to see what the future holds as we continue to unlock the power of neural networks. In closing, I'll leave you with this quote from Fei-Fei Li, who I find very inspiring, in her 2015 TED Talk about teaching computers to understand pictures. Little by little, we're giving sight to the machines. First, we teach them to see, and then they'll help us to see better. I really appreciate your time, and if you would like to reach out, please do. Thank you.